Hello everyone, welcome back. In our last video, we have seen sensor programming using the IR sensor and the light sensor. In this video, we are going to talk about ultrasound sensor. Now you must be knowing ultrasound. What is ultrasound? Ultrasound is a sound frequency which is higher than what we can hear. So that is about 20 kilohertz. Now we cannot hear that, but our electronic devices can hear that. We send a signal, it hits the obstacle and it comes back as an echo. This property of the sound is used while making ultrasound sensor. So what we do is, say I have sensor here and here is the obstacle. Now I send the sound signal goes, hits the obstacle and it returns back as an echo. Now the sound has traveled 2 times the distance between your sensor and the obstacle. We know speed of sound. We use 340 meter per second for our calculations. So we know the speed, we know the time, then we can calculate distance because we know speed is equal to distance upon time. So we know speed of sound, we know time, and that means distance becomes equal to speed into time. One important thing to note, this time is for 2 times the distance. So this is not the distance between obstacle and the sensor. This is twice the distance between obstacle and sensor. So the distance between obstacle and sensor is going to be half of this. And using this property, this formula, we can calculate the distance between our ultrasound sensor and any obstacle. Now for that, we need to create a sound wave using our sensor. And how to do that? Let's see. So what we need is a pulse like this. So this is a digital pulse, a square pulse. We need this pulse. So what is here? Here we are at a low value. This is low, this is high. So to create this pulse, what I am supposed to do is first send a low value for certain time. So this time period is, let's say, T1. At this point in time, I changed from low to high and I kept that high for time T2 and then again I made it low. So if I'm able to do this using my Arduino, I will be able to create a sound pulse, and this sound pulse will travel, will return back and will give us the distance. So let's see how we can do this. So let's go back to our Arduino IDE. Let me start writing it here. What we want to create the pulse first, and for creating the pulse we are going to first send a low value. We know it's a digital pulse, so we'll use digital write. Who is going to create a pulse? In ultrasound sensor there are 2 signal pins. One is the trigger pin, one is the echo. Trigger pin creates the sound wave, so we will use here trig. We'll check the pin number later, so first think that this is trig. So trig pin, and we want to send low. After that we want to give a delay. This delay we want to give in microseconds, and for that we have a new command in Arduino, that is delay microseconds, and we want to give it only for 2 microseconds. Then we want to do high. Trig pin high, and this we want for a little more time. Let's say 100 microseconds. And finally these 5 commands create a small ultrasound pulse at our trig pin, and this pulse is now going to travel, hit the obstacle and come back. So what we need to do is we need to measure the time taken by this pulse. And for that, there is a command called pulse in. Now this command, what it does is, as soon as the command is executed, it starts a clock, a stopwatch, I would say. And it waits for this pulse to return. And when the pulse returns back to the echo pin, it stops the clock. And it measures the distance between start and stop of the clock. So the command is pulse in. And we need to give where we are going to receive the pulse back. And so I will call that echo pin. And what kind of pulse I have sent? I have sent a high pulse. But this command returns a value. It returns the time. So I need to have a variable to capture this time. So let me create a variable. The time may be in fractions. So we are going to create a variable of type float. I'll create a variable called duration, float duration. And let's receive this value in the duration variable. So duration equal to pulse in echo high. So what does the pulse in command do? It starts the stopwatch as soon as we execute this command pulse in. It waits for the pulse to return, and when the pulse is returned back to the echo pin, it stops the clock and it calculates that time from the time it started the stopwatch and it stopped it, and that is sent into variable duration. This duration we need to convert into distance. So which means I again need one more variable to store the distance. So let me create another float type of variable, distance. And distance is equal to, so we use the formula for it. Now we know the speed of sound is 340 meters per second. We know our distances are in centimeters and the time is in microseconds. So 340 meter per second gets converted into centimeter per microsecond. And then we know distance is equal to speed into time. So 340 meters per second converted into centimeter per microsecond multiplied by the time which we received in microsecond divided by 2, because the time which we received is for sending the pulse and returning back, and that gives the distance. And if we simplify the formula, what we get is distance is equal to duration divided by 58.2. That is the distance. Now this distance is what we want to use in our main program for taking the action or comparison and action. So every time I need to write this much to read the value of my ultrasound sensor. So instead of that, what I'm going to create is I'm going to create a function module of this code. A function module named, let's say, US sensor value. The name of my function module is US sensor value. What I expect from users is they should send me what is the trig pin and what is the echo pin they are using. So I write int trig, int echo. These are the parameters I expect from the user. And what is the action? This is the action which I am going to do for my function module. I'm going to define the variables. I'm going to create a pulse. I'm going to start the pulse in the stopwatch, capture duration and convert the duration into distance. Now this distance needs to be sent back to the main program. So we are going to use a command called return. Return what? Return distance. And the type of the function module should match with the value it returns. It is returning distance and distance type is float. So the distance value has a type of float. So my function module also has type float. This means I have created a function module to read the distance of obstacle from the sensor. And this function module I'm going to use in my main program, and I write program for obstacle avoider and for edge avoider in our next videos.